Alright, welcome back. So in this video, we will fix the jumping, we'll fix the movement being slippery, we will polish up the guns with weapon sway and a muzzle flash, and just make everything a lot more polished. So let's get straight into it. The first thing you need to do is go into your movement scripts. And right now the movement is slippery because when you apply no input, it does nothing to the velocity. So basically it just keeps on going until friction kicks in inside of Unity. So what we want to do is apply our own force to come in here and slow down the player. So let's do that. In here, let's write if input dot magnitude is less than 0.5. We want to return new vector3 negative rb dot linear velocity dot x. We don't want to touch the y, so jumping up and down, so we'll just write 0. And on the z, we'll return negative rb dot linear velocity dot z. So this applies a force to the player that's completely opposite to its current velocity, and else we will return velocity change. So this new velocity that we calculated, and we can delete this old code. So if we play this, the movement is now super snappy. Now the jump is still quite weak, so let's increase the jump height to something like 25, save that. And as you can see, the gravity is very slow. So it takes a long time for us to fall to the ground. Now what you can do is you can increase the gravity for the entire project, but that'll just look unnatural. So let's increase the gravity specifically for our player. To do that, when we are not jumping, let's apply an extra gravity force onto our player. So in here, let's add a public float called extra gravity, and we'll set this equal to 10. And in here, else, so here we're applying the jumping force. Otherwise, we want to apply the gravity force. So rigid body dot add force vector3 dot down times extra gravity, and change the force mode from impulse, so that's just a sudden force, to force mode dot acceleration. Now this is nice and smooth. Let's also add sprinting to our character. So let's add a new private bool is sprinting, and we'll set is sprinting equals to input dot get key code dot left shift. Make sure this is get key and not get key down, so it should be get key. Then in our calculate movement, you see here how we are multiplying by walk speed. We want to create a sprinting speed that we can also multiply by. So let's add a public float called sprint speed, and this can be 15 by default. And we'll create a new float here, float speed to use equals to is sprinting question mark, and if we are sprinting, we'll use the sprint speed, then add a colon, and if we're not sprinting, we'll use the walk speed. And then replace the walk speed here with speed to use. So this is basically shorthand for if is sprinting do this, else do this. So that's just shorthand notation. Now we can save this, and let's test it out. Cool, we can hold shift to sprint, we can jump, and now the movement overall just feels a lot nicer. Let's add a particle for when you hit something. So if you go to the pack, if you go to prefabs and VFX, there's some particles which we will now implement. So let's first implement the stone hitting particle. Let's just wait for it to compile. So it looks like this. Let's just very quickly fix the particle. Select all of these and change the position on the X to this. And now the particle will be properly centered. So yeah, just select all these, reset the position to 0, like so. Let's do the same for the blood hit. 0, 0, like so. Cool. And so yeah, we have the stone particle. How do we instantiate it now? Over the network where we hit. So let's go to our player. Let's go to our weapon script. And I want you to think about how our local player would instantiate an instance of a prefab on everyone's computer. Maybe think about how we instantiated our player. And once you've thought about it, I'll then give you the explanation of how it's done. So I'm guessing you might have maybe tried it out for yourself, but basically what we need to do is replicate similar code to what we have here, except we'll pass in the hit location and the hit rotation. So let's create a reference to a hit particle. We'll add header, hit, particle, set up, and we'll add a public game object called concrete hits particle, like so. And if we hit something, and if this hit is not a player, so we'll do else. Here we want to instantiate the concrete hit particle. So we'll do photon network dot instantiate concrete hit particle dot name hits dot point and hits dot r. And now we need a rotation. So we want the rotation to face away from where we hit. So we'll create a quaternion rotation equals quaternion dot look rotation, and our look rotation will be hits dot normal. And we might need to flip this. We'll figure it out. There we go. So we're instantiating the particle over the network at the point of the hit and in the rotation of the normal of what we just hit. Now let's go to our particle. Let's drag it in here. And if you remember from our player, to instantiate something over the network, we need to use a photon view. So add a photon view to your stone hit. And now let's drag it in to our resources folder. Let's create an original prefab, like so. And let's go to our AK and drag in our stone hit from our resources folder into this particle setup. Okay, let's try this out. And there we go. We now have a concrete hit particle, which looks super awesome. Alrighty, and now let's also make a particle for when we hit other players. So let's create a new particle, public game object blood hit particle, or let's actually call it player hit particle for consistency. And we can just copy this. Nope. And we'll paste it inside of here. So when we actually hit a player, and instead of instantiating concrete hit particle, we'll instantiate player hit particle. And since we're using this code in both places, what we can actually do is move it outside of here, since both of these are using the same rotation, so we can just calculate it in here for cleanliness. And now let's also create the blood hits particle. So let's go to our VFX prefabs, get our blood hits, make sure that the positions of these are 0, and we'll need to add a photon view to it. So we'll add a photon view to the blood hit and drag it into our resources. Create an original prefab and drag it in here. Now next, let's add some muzzle flash to our weapon. So under your AK, let's add a new empty game object right here, and we'll add it to the tip of the gun. So just go into here, go into orthographic mode, and try to align it as best as you can with the tip. That looks pretty good. And we will call this muzzle flash instantiate. Oh, and one more thing. If we just instantiate these particles, they will never get destroyed. They'll just stay here, which is a performance issue. So let's add a script to both of these particles that destroys them after some time. So we'll add a new script called timed object destructor. This will take in a public float lifetime, and we want to destroy this over photon. So let's do mono behavior pun up here and add a using photon.pun. And if you remember here, we only destroy our player. Oh, if you remember here, we can only destroy our player via photon if we are the creator of the player. And there is a similar logic to calling photon destroy for our particle. So first we'll check if photon view dot is mine. So if we are the ones who created this object over the network, well, then we want to run our destruction code. So we'll add a new void called destroy. Actually, we'll make a IE numerator and add using system.collections, and we'll call this delayed destroy. We'll add a yield return new, wait for seconds, and we'll wait for our lifetime. So wait for seconds lifetime. Let's set this equal to 3 by default. Add a semicolon, and then after we've waited, we'll do photon network dot destroy game object. So that's this game object, and in here we'll call start coroutine delayed destroy. Very nice. Almost forgot, so it's a pretty important optimization to do. So make sure that you have a timed object destructor on your blood hits. Set the lifetime to 3. On your stone hits, add a timed object destructor and set the lifetime to 3 as well. All right, back to our player. Let's add a muzzle flash. So in your weapon, let's add a new header called muzzle flash set up. We'll add a public transform called muzzle flash spawn point, and we'll add a public game object called muzzle flash prefab. So when we shoot, we want to instantiate the muzzle flash prefab at our muzzle flash spawn point. So we'll instantiate, and this won't be via the network. this muzzle flash will be only for us, since this is the first person hands. We'll have a separate third person hands later on. So we'll instantiate muzzle flash prefab as muzzle flash point, and as muzzle flash point dot, oh, this should just work. And we want to destroy this muzzle flash around, the muzzle flash should have a duration of like 0.1 seconds. So we'll destroy, we'll do game object muzzle flash go equals instantiate, and then we'll destroy muzzle flash go after 0.1 seconds. Can be even shorter, 0.08 seconds. Next, let's drag in our muzzle flash spawn point, and we'll drag in our muzzle flash variant, and let's test this out. And you can't really see it, so let's increase the lifetime to maybe 1, for example. And we still can't see it, so let's see what's going on. Alright, so let's just properly do this. So we'll do muzzle flash spawn point dot position, muzzle flash spawn point dot rotation, and then we'll do muzzle flash go dot transform dot parent equals muzzle flash spawn point. So change it to this, and let's see if that fixes it. Alright, we're having a weird bug with Unity. I think let's drag the muzzle flash instantiate outside of the rig and just into the AK, like so. There we go. Now it's just aligned a bit wrong, so we will rotate this like so, and we will decrease the size of our muzzle flash. So let's make it maybe 0.5 on each. Let's see how this looks. Let's make it a bit smaller. So let's make it 0.25. And let's fix it looping over and over. So go to your muzzle flash variant and just uncheck looping right here. And let's give this a play and see how it looks. Yeah, it looks pretty awesome. Now let's add some weapon sway to our weapon, because it's looking pretty stiff right now. Under your first person camera, create an empty game object. We'll call this sway holder. Move it to the top, reset the position, and let's drag our AK under the sway holder. And we'll add components, and we'll call it sway. Let's delete all this. We'll add a public float sway clamp. And we'll set this equal to 0.09F. And we'll add a public float called smoothing, and let's set this equal to 3F. Then we'll make a private vector3 called origin, like so, and we'll make the start method. And we'll set origin equal to transform.local position. Make sure this is local position and not regular position. Then in update, we'll set vector2 input equal to, and we can copy this from our Muzzle script. So just copy this, paste it in here. So new vector2 input.getAxis raw mouse x, comma input.getAxis raw mouse y. Then we want to clamp our input by our sway clamp. So that's the maximum. So that's the maximum sway that will allow. So we'll do input.x equals mathf.clamp input.x, and we'll clamp it. So the minimum will be negative sway clamp, and the maximum will be positive sway clamp. And we'll do the same for input dot y. So just replace x with y and x with y here. Then we'll create vector 3 target equal to new vector 3 negative input dot x and negative input dot y. And for z, we'll put 0. So we're swaying the game object left and right, basically the opposite way of input. So it looks like it lags behind our mouse inputs. And then we'll set transform dot local position equals to vector 3 dot lerp transform dot local position. So from our local position to our target plus origin. So we're applying the sway to the original position. And over time, so time dot delta time times smoothing. Add a semicolon and save this. Very nice. So now we have some super cool weapon sway. And you can obviously tune this to your preferences. So if you want it to be less sway, you can make it 0.03. I'll keep it at around maybe 0.5. I think that would be quite good. Next, let's add some sound effects. Now, we don't want these sound effects to just be played for us. We want these sound effects to be played for every instance of our player on the network. So if you recall to our player health, we used PUN RPC to call a function for every instance of this photon view on the network. So we'll do a similar thing for our weapon sounds. So right click, create empty, and we'll call this weapon sounds holder. And we'll create an empty game object called weapon sound source and add an audio source component to it. Make the spatial blend 3D, so it's in 3D space, and change the min distance to 20. The max distance looks pretty good as is. Maybe make it 150 instead. Uncheck play on awake. And now let's create a manager to manage all of our sound effects. Let's just rename this to player sounds holder. Nice. And on our player game object with the photon view, let's add a new script called photon player sounds manager. Let's also organize our project a bit. So right click, create a new folder for our scripts, and we'll drag all of our scripts except for this readme into here. Very nice. All right, let's work on our photon player sound manager. So through these PUN RPC functions, we can only pass a limited amount of data types. We can pass in an int, a float, a vector 2, a vector 3. This is vector. You can pass through a quaternion, a byte, a string, a short, what else? A boolean. But you can't pass through an audio clip. That's the important bits. And you wouldn't really want to, because that's really inefficient. Like, these audio clips are 3 or 4 megabytes. So how do you handle playing a specific weapon sound using this function? Well, what you do is you pass in a integer for the index of sounds that you want to play. So we'll add a public audio clip array called shoot sound effects. We'll also add a public audio source called shoot source, and we'll make a PUN RPC, add using photon.pun at the top, and add mono behavior PUN here. And we'll call it public void RPC play shoot sound. And this will take in, let's do a byte. So a byte is basically the same as an int, except it can only have 255 values, so it's smaller. So 1 byte in Photon is equal to 2 bytes, I think. Maybe it's just 1 byte. But 1 integer in Photon is equal to something like, I think it was either 3 or 5 bytes. So a byte is 3 to 5 times smaller than an integer. And the range of a byte is 0 to 255. And the range for an int is 0 to like 1 million or something. Probably higher. I think it's some really high number. So unless you have a lot of shoot sound effects, a byte should do. So RPC play shoot sound bytes index, and we'll do shoot source dot clip equals shoot sound effects index, and we'll do shoot source dot play. We'll do shoot source dot stop beforehand, like so. And we'll add a public void. Actually, that should be fine. Cool. So what's happening is we have a list of all the shoot sound effects in our game, and we pass in which index of the list we want to play, and then we play that. Now let's trigger this inside of our weapon. So go to your weapon, go to hit scan shoot, and we want a reference to the player shoot sounds manager. Now this is on the root of our player, so we'll just do, let's just get a proper reference. So we'll do header shoot sound effects. We'll add a public Photon player sounds manager, Photon called Photon player sounds manager. We'll add a space, and to make sure it's a public byte, not int, byte shoot sound index, and this can be equal to 0. So now when we shoot, we'll do Photon shoot sounds manager dot Photon view dot RPC. The name of our RPC is RPC play shoot sound. This will be for RPC targets dot all. So everyone, not buffered, because we don't want the sound to play for players that join after the shoot happened. So RPC targets dot all, and we'll pass in our shoot sound index. So our AK, let's drag in our shoot sound index, and our index for now is 0. Now in our player sounds manager, let's drag in our weapon sound source, and let's drag in all of our shoot sound effects. So just go to the pack, go to audio, go to gunshots, and we have all of these gunshots. Press this lock icon to lock this, and this icon, select your AK and press this icon to lock this. Shift, select all of these. Select your player, sorry, and then press the lock icon. Shift, select all of these, and just drag them and drop them in here. So the first, so index 0 is AK, index 1 and 2 are shotgun sounds, 3 is sniper, and 4 and 5 are suppressed gun sounds. Nice. So here, this will play index 0. So AK. Over the network. Let's try it out. Now a feature a lot of other games use ammo. So let's implement that along with reloading. Let's first make some UI for ammo. So go into 2D mode, go into your canvas, which is under the camera, and let's duplicate our health holder, and we'll rename this one to ammo holder, and maybe you want to put it above or you can put it on opposite sides. I don't know if players want that. Let's just put it here. Let's do above. I think that's most appropriate. We'll make this a bit shorter, so maybe 70. We'll tint it blue. We'll make the indicator white, or maybe blue. White looks good. And we'll make the text called ammo text. We'll make this the ammo indicator. And yeah, that looks pretty good. Let's change the font on both of the texts to Roboto. Nice. And let's increase the outline on these indicators. Maybe to 1.5. Very nice. Alright, let's set up the ammo. So in our AK, let's get a reference to our ammo UI. So we'll create a new header, ammo setup. We'll add a public int called mag size. We'll add a public int current ammo in mag, like so. Then let's add a space, and we'll add a public text mesh pro UGI. Make sure to add using TM Pro, and this will be called ammo text, and we'll add a public image, add using Unity engine.ui, and this will be called ammo indicator. Let's copy this update UI method here and paste it in our weapon, but replace health text with ammo text. Replace health with current ammo and mag, and replace max health with mag size. We'll replace health fill image with ammo indicator, and replace health with current ammo in mag, and max health with mag size. On start, we'll update UI. Let's rename this to update ammo UI. So just rename it here and here. In most code editors, it's F2 or Control or Command R to rename, or you can do it manually. Next, every time we shoot, we want ammo, current ammo in mag, minus minus. So that's the same as current ammo in mag equals current ammo in mag minus 1. So it just subtracts 1. That's the shorthand for it. And we also want to block the fire if current ammo in mag is 0. So in here, we'll do and current ammo in mag is greater than 0. So we'll only fire if all these conditions are met, so we have at least 1 bullet in the magazine. Now let's add a reload. So we'll add a private void reload, and let's add our reload animation. So we'll add a public animation called reload clip. And in here, we'll do anim.clip equals reload clip. And this clip should be an animation clip, like here. And then we'll do anim.stop, anim.play. And we'll set ammo, current ammo in mag equal to mag size. Now we'll trigger the reload, so we'll do if input dot get key down key code dot r. Then we'll trigger our reload, like so. And we also want to block the fire if we are currently playing, well, like mid through playing the reload clip. So we'll add a private bool is playing reload clip. And we will return anim.isPlaying and anim.clip is equal to reload clip. And we will also check and not is playing reload clip. Make sure this is a private bool. So this is returning a true or false value, and we're doing the opposite of it to allow to fire. Let's set some sensible values for the mag size. So 30, current ammo in mag equals 30. So let's drag in the reload clip into here. Make sure it's also in these animation list. And we'll set the mag size and current ammo in mag to 30. Let's drag in our ammo text. So ammo text and ammo indicator. And let's play this. Now, we forgot to update the UI every time we decrease the ammo. So in here, we'll call update ammo UI. And after we reload, we'll also call update ammo UI. Now, I know this is quite a long video. Maybe I'll break it into 2 parts, but let's add sound effects to the reload next. And then maybe we'll add, I don't know, we'll see. We run out of ammo, we can't shoot anymore. We reload, we can't shoot while reloading. Now let's go to our crosshair and let's create a hit marker. So duplicate your crosshair and change the sprite to the hit marker sprite. Let's make it a bit smaller, so maybe 70 by 70, maybe even 60. Let's change the color to red, make it sort of transparent, and I'll call this hit marker. And we want to create an animation for this. So add component, animation, press Ctrl or Command 6 or go to Window, Animation, Animation, and let's create an animation clip. Save this in your project. I'm just trying to find out where my project is. There we go. I'll create a new folder for animations, and I'll create a new folder in that for UI animations, and this animation will be called hit marker. Make the hit marker scale 0, 0 by default. Press this record icon. Let's move forward 30 frames. We'll make it 1.1, 1.1, and make the color fully transparent by default. And then we'll make it have a transparency of 150. So it looks like this. Let's actually move this to frame 15. Then at frame 30, change the scale to 1, 1. And yep, copy this image color and paste it on frame 30 as well. And then from here, we will fade out the hit marker. So we'll set the scale to 0, 0 and set the color to fully transparent. So if you play this, and you can obviously adjust this. So you can make it a bit quicker. I think this looks quite good. And let's drag this animation into this current animation clip here. Uncheck play on awake. And let's add a sound effects to it as well. So we'll add an audio source called and we'll drag in our in others hit marker sound effect. Nice. Uncheck play on awake. Make sure it's 2D. And let's play the sound whenever we get a hit. Now let's make a new script on our player called player and kills manager. Now we're creating a separate script, since this script will be responsible for like saving score to leaderboards, leveling you up, and like playing hit markers. So it'll be in a separate script to the weapon just for organization. Let's just drag it into here. And in here, let's set up our UI. So we'll add a header for UI. We'll add a public animation called marker animation, and we'll add a public audio source for marker audio source. We'll add a public void for get hit. Nice. And we'll do hit marker animation dot stop and hit marker animation dot play. The reason we do stop beforehand is if it's mid animation, this won't trigger, so we stop it if it's mid animation and just restart the animation from the beginning. We'll do hit marker audio source dot play, hit marker audio source dot stop. Nice. Now we want to call this from our weapon. So in our weapon, we will get a reference to header kills manager, and we'll add a public player hits and kills manager called player hits and kills manager. Now in here, if we are hitting a player, we know we got a hit on a player. So let's do player hits and kills manager does gets hit. So let's drag in our animation to the hit marker, drag in our audio source to the hit marker, and drag in our player hits and kills manager into our weapon. I'll make sure the hit marker has this animation set here and the audio source set. Now we will test this in 1 second. Let's also add reload sounds. So go to your player, and on our AK, get out of 2D mode. If you go to your reload animation, we want to play certain clips at certain parts of the animation. So we're going to use Unity's events system to achieve that. Actually, you know what? I know this video is going hopelessly super long, but let's also add a kill marker. So duplicate the hit marker, make it kill marker, and make the hit marker's color, instead of red, let's make this one white. And change the sound effects on the kill marker to kill. Change RPC take damage from all to all buffered. So it buffers it for new players that join. So everyone will have an accurate sense of the damage which each player has taken, and hence the health. And here we will check if we get a hit or a kill. To do that, we'll do hit.transform.get components, player health. All right, so copy this. I'll do if hit.transform.get components player health is less than 0. All right, dot health. The health is private. Let's go here. Go to your player health. Make the int health public, but we don't want this to show up in the inspector. So in square brackets, type hide in inspector, so it won't show up here. Dot health is less than or equal to 0. Let's add a new method for get kill. So space And let's duplicate these. Public animation, kill marker animation, and public audio source, kill marker audio source. And let's make a new function called get kill. And paste this here. Yeah, so here it's just damage. Here it's a kill. Here we get hits. Here we get the kill. Yep, and also another thing, let's just make something. So photonnetwork.destroy will take a while to sync. It might take like 0.2 seconds. By the time this guy gets the take damage alert, and then he realizes he has less than 0 health, and then he gets destroyed. So what we want to do is update this immediately on all players, but we can't call photonnetwork.destroy. What we can do, let's do it here. So if I'm not the creator of this player, and if health is less than or equal to 0, we'll do game object dot set active false. So just it hides the player until we receive the actual destroy command. Nice. And this should do. Let's drag in our kill marker. Kill marker. Kill marker. Nice. And yeah, back to the reload sounds. Sorry, I keep getting sidetracked. So let's add a new component called reload sound manager. And there's two main things that we want to play sounds for. So we have swapping out the mag out, mag in, and on this side we have pulling the slide, I think. I don't know. So yeah, let's create those. So we'll add a public audio source mag and we'll require components. Actually, no, it should be fine. We'll add a private audio source. Oh no, never mind. Yeah, this should do. Space. We'll add a public audio clip mag in sound. We'll add a public audio clip mag out sound, and we'll add a public audio clip slide sound. We'll add a public void play mag in sound, and we'll do mag audio source dot play one shot mag in sound, and we'll just make methods for each. So mag out sound, we'll play the mag out sound, and play slide sound, we'll play the slide sound. Cool. Let's add our reload sounds. So we have we'll just have a mag replay sound. So we'll do this one. We'll add an audio source component. We'll drag this into here, and we'll have a slide sound. So in our animation, go to the reload. Here, when the mag is being replaced, click here to add an event. The function should be reload sound manager dot play mag in sound. Make sure that this reload sound manager is on the same game object as the animation, or else you won't be able to call events like this. So yeah, replace sound, and let's play the slide sound here. Reload sound manager dot play slide sound. And let's try this out. And then we'll test the hit marker and the blood as well. Yeah, so the mag is sort of disappearing right here. So the way to fix that is select all of these, the AK, arms, and mag, and check update when off screen. It's just being called incorrectly. And yeah, this should be mag replace. Let's make this just mag. So the mag in sound will be mag. The mag out sound will be mag replace. And let's just fix that. So we want the mag in sound to play here. So this is the play mag in sound. And we want the mag replace sound to play maybe here. So we'll add an event here to play the mag out sound. Maybe this will look better. Let's just align it a bit better. That one looks good. Maybe this one should be here. And let's remove the slide sound. And let's just build this to test the hit marker. Okie doke, let's test. So you hear the sound playing twice because it's being synced. So there's a bit of a delay. There's a hit marker. Boom, you got a kill. Oh, that's so cool. This is so satisfying. I'll just do one more thing, which is to make the hit marker a bit smaller, so that the kill marker looks bigger. And then after that, that's the end of this video. Cool. See you in the next one.